Hi, this is Ram from Crossmind Studio and welcome back to the fourth chapter of Mantaflow Introduction Series. In previous chapters, we mainly talked about the very basics of fluid simulation system and the main principles and only discussed the smoke and fire simulation parameters. But today's focus is going to be the liquid simulations. Even though there are quite similarities in the way the both kind of simulation system are set up, but there are few things specific to liquid simulation that we need to address today and in the following chapters. So that is what we are going to do today. We'll talk about the very basic parameters first and then get into a few of the example and different use case scenarios and end this tutorial with the example that you've seen in the trailer. For those of you who are absolutely new to Mantaflow and only interested in liquid simulation, even to them I'll suggest that you watch the very first chapter of this series. That was about smoke and fire simulation, but a lot of things that we might have discussed over there could still be useful for this chapter as well. And if you are absolutely new to this channel, do check out the playlist section for different tutorial series we have discussed in the past and ongoing series. And do subscribe if you want to stay updated for the future updates. So I have this very basic startup file that we get. So I'm going to make a very basic setup to discuss all the initial parameters. Let me just make this cube really small for this example. Now the very quick way of setting up the basics of liquid simulation is going to quick effect and click on the quick liquid preset. And this will convert your main geometry into emitter and create a domain around it. Now just so that you understand what is going under the hood, I'll recreate this one without the help of preset. So basically we need two things essentially for any fluid simulation to happen. One is the domain and one is the smoke or liquid source. So let's create one cube and place it in the center and make it around this toggle. I'll call this one domain and I'll call this one flow source. Now in the physics properties over here, I'll assign one fluid properties to this cube over here and change this one to flow source. And in the flow type, we want this to be liquid. So let's make this liquid and select the cube that we have made for the purpose of domain and apply fluid properties to this one as well. Let's change this one to domain. Now make sure you change this domain to liquid as well. Otherwise you won't see anything happening. So as soon as I do that, you'll see we have some particles which are emitting from the volume of this flow source. And if I hit play, those particles will fall on the ground and behave like a liquid simulation. I'll just make background a little darker just so that you can see what's going on. So this is a very basic setup. Right now there is nothing much happening over here, and we'll detail it out in a moment. So there are two kind of properties. One is when we select the flow source, you'll see few properties regarding flow source. And if you select the domain, this will give you much more all those detailed parameters about the look of the simulation. This is where you'll be spending most of your time when setting up the smoke or liquid simulation. Now, anytime you play the simulation, this basically creates a cache for your for simulation. And now you can go back and forth and replay it. But if you make any changes, let's say if I increase the resolution a bit, this will reset the simulation and now this will recalculate your simulation again. But this doesn't work if you change the settings of the flow source. So let's say if I increase the sampling substeps over here, in this case it won't reset. Now to reset that, you'll have to again go back to the domain and change any of the settings, and that will reset the cache that was already baked. And if you want to manually bake it, just make sure you are into modular, and this way you'll be able to bake your simulation in one go and cancel it anytime you want and resume it. So when you're dealing with the high resolution simulations, you would want to make it modular. That is a much better way of dealing with the high resolution simulations. So I'll make it replay for now. So let's talk about all those basic parameters for now. So the liquid simulation will give you particles which behave like liquid, and in itself it's not going to create anything exciting unless you put some work into the emitter source or the motion of the emitter. In itself, water, it's just going to go down like a water, and maybe at some point of time it will become still. For any simulation to look good, you'll have to put some thoughts into what kind of emitter source you're using, the motion of the emitter, and all that. We'll get to that in a moment. The first thing I want to talk about is the resolution division. We discussed this in smoke simulation chapter as well. So this cube over here, the domain cube, you see, it has this little voxel in the side. And this is basically the resolution of the simulation. And the very first rule of simulation is the liquid or the smoke simulation is that you would want to wrap your domain as tightly as possible around the simulation and don't make it unnecessarily so big that the resolution goes to waste. You'll have to keep that in mind that this little voxel you see over here, this is a shared resolution. And let's say if I want my liquid simulation to be only this much, like it falls on the floor, creates a little splash, if I want only this much simulation, but for this little simulation, if I end up making this big domain, then what will happen is all these empty areas, unnecessary calculations will slow down my simulation. And if you look at over here, this voxel size, it also increases in size with the domain scale. You would think that increasing resolution would solve this. It does, but then it's totally unnecessary, and now it would the solver will have to think so many more voxels just to accommodate for such small simulation. So keep that in mind. Now if I make this one tighter, this will have much more resolution for our simulation. So this is something you should always think about before starting a simulation, and very carefully set it up. Right now if I play my simulation, you can see I have quite a lot of particles being emitted because the voxel size is much smaller than the emitter size. But let's say if I make the domain much larger, like this much, and reset my simulation, just shuffle any number, this will reset it. There aren't any particles being emitted because this resolution cube is much bigger than this flow source. Let me make it much smaller. Now there are only very few particles which are being emitted because there is not much room in this resolution to fit in this many particles inside this flow source. So it's something which you will get used to after setting up very few simulations. So don't worry about it too much. The only thing to keep in mind is just tightly wrap your domain box around the simulation wherever it needs to happen according to the scene, and that's about it. Forget this resolution cube and just focus on the domain size. So we have this very basic simulation. Alright, so about the resolution, one thing to keep in mind is the scale of the domain, and second thing is the resolution. You can always set it from here. For this, I have never went above like around 180 or 256 is the max resolution you would want to use. And so as soon as I make it 64, you'll see since our voxel became much finer, there are much more particles which can actually fit into the volume of this flow source. So we can see we have much more particles going on over here. And these particles basically later will help us generate the mesh for it. So the more particles we have, the much more detailed the mesh is going to be. And there are many ways to increase the number of particles. One is the resolution, one is the sampling over here, and one is the time steps. And we'll discuss this one by one. The first thing I want to discuss is the resolution division. And so 64 looks like this. If I make it 128, it should give you a really nice detailed simulation. But as you can notice, it's much slower, but there is everything have much more detail. So I'm going to keep it only 50 frames for now, just for the testing purpose and just to cover all these basic things about the flow source. But the resolution is not the only thing about the which controls the quality of the simulation. And before I get into any of the other parameters, I want to talk about one more thing, which is the time steps, which is I think the most crucial thing about the simulation over here. Let's make it 32 and let's see what is going on when the particles are emitted. I'll just make this one 64. So over here, if you notice, even though we have particles which are behaving like liquid, but there is a very little information about the flow of the fluid. Right now the simulation is only calculating 4 steps. For each frame, it would take a previous 4 frames. I think something like that for into consideration and make generate the next frame. And that is what we see over here. For a really high detailed simulation, these basic values sometimes won't really work. If you want to add much more detail into the flow of the liquid and the overall, there is some sort of constraint which the fluid solver have. I'm not sure what's the right word for it or what is the technicality behind it. But think about it like the much more information we can feed into this solver about the motion of each particle, then it will be able to generate much more accurate fluid simulation for us. So right now, if we give it only the 4 time steps, then it will give us a fluid simulation, but even then it's quite basic. Now you will see the difference as soon as I increase this up. Let's make this one 24 just to exaggerate what I'm talking about. Now each of those particles have 24 samples of the previous frames, and you can see all those trails generated for each of the particle, and you can actually follow the flow of the fluid. And these particles will later help us create a much more detailed mesh. I hope you can see the difference. Let me just play it side by side for you. So over here we can see the trails of the particles, and we can read the flow of the fluid much more easily, and these particles forming in the much nicer flow will help us generate much better mesh for it. Now I don't want to really jump onto the mesh, but just for the sake of this, I'll just make a very simple preview. Now over here on the frame 35, you can see each of the waves properly forming, and there is a lot of detail going on. Even though it's just a 64 resolution sim, we can see the details of the wave. But if I decrease this to default value, the time steps, all those particles will look much more random, and there won't be really like a follow-up motion like a wave. Over here you see, if I go to the frame 35 that we discussed, there is no wave over here, and that's the difference. It becomes much more obvious when you're dealing with much higher resolution simulations. We'll talk about this in a moment, and it's also very crucial for the diffusion parameters. So I don't want to mix it up at this moment, and we'll make use of this parameter when we discuss further examples. So let me just make it 16 by 4. So these are the most important parameters that you need to initially set it up. Before getting into any of other properties, I want to talk about the simple stuff first, which is the flow source parameter. So right now we're dealing with the geometry flow behavior, and in the flow behavior there are 3 things: inflow, outflow, and geometry. So inflow is basically, it would work just like faucet. Let me just reset this one. Shuffle these numbers to reset the cache. It will constantly pour liquid into the scene. I'll make this cube smaller so that we don't have so many heavy particles piling up over here, and so we can see the results faster. So this is inflow. If you make it to geometry, then the particles will only form within the volume, and that much particle will fall on the ground. And the outflow is basically, let me make this one inflow, and I'll make a duplicate of this, scale it up, and I'll make this one outflow. So outflow basically kills the particles. Anything that will collide with outflow object will exit the simulation. The use of this, you may ask, let's say if you're dealing with a scene where you have extreme tight close-up, and over here you're focusing on the fluid, anything that exits the camera, you want to kill those particles. just so that your simulation doesn't become heavy. So you can make an outflow object, and that will kill the particles. So that's basically what the outflow is about. And there is other way to kill the particles. Basically, if you select the domain object, you have border collisions over here. If you deactivate this, now your particles will not collide over here, and this domain will not work like a tank. So it will just exit the simulation over here unless you have some collision object over here. All right, these are the three different kind of flow behavior types. And in the sampling substeps, so sampling substeps will help you. Let's say if you have really fast moving object, I'll make something like this, and let's say if this object have one key over here, and if I make this object move really fast from here to here, if it goes, and it also rotates, I think by default sampling substeps is set to 0. If I play the simulation now, you'll see these substeps. That is because the simulator doesn't have enough steps to count the motion between for such fast moving object. And if you're dealing with something like really fast, you can increase the substeps. If I make it like 4 and reset the simulation, then you will see a much more smoother transition over here. And that's basically sampling substeps is about. All right. Let's delete this animation and reset the simulation, and let's make this cube this large, set a key, and let's make it over here. So my cube have some motion now. It's going on like this. I wanted to talk about initial velocity first. So initial velocity will give you a few different kind of velocities which you can use for your flow source. Let's say I'll make it 32 for now. So right now if I play the simulation, sorry, let me make it smaller, and I'll just make the simulation a little slower so that it doesn't fill up so fast. So right now our fluid is basically just falling down, and it doesn't have any given velocity in the normal direction or the source direction. Our fluid source is rotating, and if you want to use that velocity that is generated by the source, then you can enable this option, and in the source over here you can just give it some higher number just to discuss this example. And now if I play the simulation, you'll see in the direction however this cube rotates, you'll see that velocity affecting our fluid, and right now it's too much. I know I have given it a really high number. Let's make it 2 and reset the simulation. So that rotation will affect our fluid, and you can see these particles going. Right now it's taking this turn, and now it's taking turn over here. So all that is adding into the simulation. So you can use this if you want to add detail into your simulation. Let's make it 3 and see the difference. So instead of fluid just falling down, it's also taking the velocity that is generated by the flow source into consideration and adding that into fluid, the liquid simulation. So this looks exciting, definitely. So I'm going to make this one 0, and now let's talk about the normal velocity. So without any velocity, you'll see it's just dropping down with the basic simulation. Now, if I want this object to have a normal velocity, like if you go to the edit mode, you can see all these vertices have this normal, and we can use that to create velocity. So if I make this 5 normal velocity, then our fluid will have velocity in the direction of the normal. So all those 4 normal points, you can see over here in the 4 corners, you can see the velocity being generated by these normals. So I'll just rename this scene to basics, and just in case if you guys need this file later. So these are 2 different kind of velocities, and then after that we have initial x, initial y, initial z, and as the name suggests, this will basically add into your x, y or z direction. And let's say if I make z direction 5, then my fluid will, as soon as it emits, it's just going to bounce and go to the roof. So that is the initial velocity. even the 2 is too much, I guess. I think I'll have to make it around 0.5 to make something meaningful. So now the fluid, along with the normals, it also have a z velocity, which is making it go upwards. I'll make it 1 and see if we can see some good results. And now we have a normal velocity and a z velocity, which is pushing it upwards. Now let's make it more exciting. Let's add 2 into source, and let's see if we can get something good out of it. So we have all 3 kind of velocities working. I think it will create some really nice, interesting, swirly fluid for us. So yeah, that's about it for the source parameters. There's one more thing about this, that is flow source. In the flow source, you have a surface emission. Right now, as you see, the particles, when they are emitted from the volume of this object. But in case, let's say, if you want to add some more particles to it, or if you want to, let's say, dealing with a plane object, and the plane doesn't have a volume. In that case, you would want to increase the surface emission over here. And this will basically, let me just make it 1 and show you what I mean. So now the particles will emit not only within the volume, let's make it 2, but around this volume as well. And you can see now we have much more particles inside and outside of the cube. So that's about it for the flow source. And now let's talk about the domain object. I really like this simulation, and I think now you can see there are a lot of trails going on over here, and that is because we made this simulation on really high number of time steps, and it looks really nice. And yeah, so I'll save it, and let's make a duplicate of full scene, and I'll make this one domain. Let's make this one collision. Let's talk about collision object. So for the collision object, let's make one UV sphere over here. There's nothing much about collision object. It's just that from here in the fluid properties, instead of domain or flow, make it effector, and in the effector choose collision and not the guide. So there are 2 kind of effector, collision and the guide. The collision is basically just a collider, and the fluid is going to just collide with it. And if it's a sticky fluid, like with a viscosity or something, then it's going to stick to it. But the guide is basically, let's say if you have some sort of ship going on, and there are turbines or something. If you want the turbines, the motion of the turbine to affect the fluid, then you can use that as a guide. And we'll create an example, so don't worry about that. So right now, I'll just reset my cube's location, rotation and scale, and just place it over here and delete the animation that we created and just reset it. So we have fluid that is emitted from this cube, and since we have the normal and source velocity going on, it's giving us these random splashes. So I'm going to keep it. It looks nice, and I'll just decrease the size of the substeps just so that we can see the results faster, and increase the scale of this, and let's decrease the normal velocity. So the fluid is basically going to collide with. So this is a very basic setup for the collision. There is nothing much going on over here, but in some cases, if you ever find like some particles are going through the surface, then in that case you would want to add some more mesh to the collision object. So if I want to have some distance like in this and the particles, so you can add some surface thickness in the collision properties. Let's make it 0.1. So I made the collision to 1 surface thickness, and now you can see there is some gap between the collision and the surface, the particles. And in some cases you might would need this. And also there is a sampling substeps over here. In case if your collision object have some sort of motion, I'll just make it surface thickness to 0 and give some rotation to the sphere over here. Let's make it a rotation RZ, rotate it in this direction, and let's copy the same key over here as well. Now in this case, if you want this motion to register well, then you might would need to increase the sampling substeps. Or let's say if it was really fast moving motion that we already discussed, and you want that to register it, then you would have to increase this number. So I'm just going to make it 0 and see how it behaves on the default values. So as you can see, we have some motion into the collider object that will also affect our particles. And if I increase the samples for this one, so now that we have much more sampling substeps in the collision object, you can see all that rotation that is happening in this collision object is calculated accurately, and it's actually showing into the fluid simulation. And we have like really nice swirly motion going on over here. So it's self-explanatory, but I just wanted to give you some examples. So that's about it for the different type of fluid sources and flow source parameters. Now let's jump into a few parameters over in the domain area. So in the fluid section, we have discussed the resolution and the time steps, and that's about it. After that, we have gravity and all. I don't think you need to tweak this one unless you're dealing with some really special scene. And the time scale is to control the speed of the simulation. If I make this one 1, then the simulation, that is the default speed of the simulation. Let me just bake it. So this is the default speed of the simulation. You can slow this down. Let's make it 0.3. Now you can see our simulation is much more slower, and the fluid is falling really slow. Depending on the requirement of the scene, you can just play around with these parameters. The speed of the simulation combined with the diffusion parameters can actually help you create something like really viscous and the thick fluid, something like the melting chocolate or something. We'll talk about that in a moment. So we already discussed the border collisions, and so this area is covered. And after that, we have a few things about the particles. Simulation method that is used by Mantaflow is flip. And over here, there's a ratio. This ratio will let you choose between whether you want to use PIC or flip simulation. So PIC, if I make this one 0, and I'll just show you an example. So the PIC by default on the 0, you'll get a less splashy fluid. As you can see over here, it's basically just falling down. There are no splashes going on, even though we have velocity in the normals. Most of the time you won't be dealing with this one, but just so that you know what the meaning of this solver is, I'll give you this example. And so there are no splashes, and it has less energy, and I'm not quite sure the exact words for this one, but if I make it 100% flip, then in that case the particles are going to have the full ratio of the flip solver. And now since I made it 1, it has even more flashy motion. So by default this value is 0.970, and most of the time you might won't have to tweak this. I would suggest that you play around with these settings and see. There might be different use case scenarios for different flip ratios. I'm still doing my experiments with this as well. So that is about the flip ratio. The more flip ratio you have, the much more splashy particles will be. And after that, we have particle radius. So the particle radius by default is set to 1, and that is what we have been dealing with so far. But you can increase the scale of the particles. Let's make this 2. So this will basically increase the scale of the particles. As you can see over here, we have much more thicker particles than what we had before. And in case you're dealing with some simulations where the particle is kind of leaking from the collider object, then in that case you would want to increase the particle size. But beyond 2, it just doesn't work. So just keep that in mind. And I haven't really found much use of this, honestly. So I'm going to just skip this one for now. And particle sampling, you can control how many particles you want. The default value is set to 2. But you can increase it maximum to 5, and on the 5 you'll have much more particles. So on the frame 1, this is the 5, and if I make this one 1, then you'll have much less particles. On the 2 we have this much, 3 we have this much. So the more particles you have, definitely it's going to detail out your simulation on the cost of the performance. So keep that in mind. And in case you're making something like a crown splash where you need some more particles in the splash part, then you would need to increase the sampling of the particles if you feel there are a very few particles in some certain areas. So you can do that. So now we have more particles. If I increase this to 5, I think we'll have even more particles. As you can see, we have much thicker bands and much more particles going on, even though we don't have any diffusion parameters going on at this moment. But because of the time scale factor, which is set to really low, it's giving us some interesting results. So yeah, that's particle sampling, and randomness is basically how randomly you want the distribution of the particle. So you would want to keep it to 0.1 and just play around with this one if you need. I think it's going to be really rare case scenario where you would need to tweak this one. Particle maximum, like how many maximum particles you want within one voxel, and particle minimum, the minimum number of particles within one voxel. And the next parameter is narrow bandwidth, and I haven't really been able to understand this one, but essentially I think this means it's more or less related to the sampling of the particle. And if I make this one 1, you'll see for each of the band we have much less particles. Over here you'll see all that detail is gone, and if I make it to 5, then you'll be able to see much more particles forming those thicker bands. Alright. So correct me if I'm mistaken about this. I'm not quite sure about this parameter, honestly. So I'll leave it to 3 by default. And now let's talk about the diffusion, which is the really exciting part. So the diffusion basically lets you define the behavior of your fluid, if it's going to be water or if it's going to be honey, chocolate, different kind of fluids have different properties, liquids have different properties. So you can do that. You can enable this option over here to gain access to all those parameters, which will let you define the property for the liquid. So by default it's set to 1 and 6, and if I play the simulation, so by default you get the water kind of properties for the liquid, and over here there are few presets like honey, oil and water. And if I choose honey, then you'll be able to see completely different behavior for the liquid over here. It will behave like a much thicker fluid and splash less and stick to the surface. Yeah, now it's splashing a little less, but I think it will be much more obvious if I make a slightly better example for this one. Let me just make the domain this big, and let's move it over here, scale this much. All right, so what I'll do is I'll just create one Y location key and assign this very simple motion, which is a built-in function. So basically I want this cube to move like this, and amplitude I can slow this down, phase modifier 0.5 and amplitude to 0.5. Alright, and I'll disable the initial velocity on this emitter. And now what we have over here is a basic liquid that is falling down. I'll just reset, I'll just disable the diffusion so you guys can see the difference. Alright, keep in mind I'm using Timesteps to 16 and 8, and right now if I bake the simulation, this is the default diffusion setting. It's basically going to just fall down and behave like water. So this is water preset, yeah, behaving like water, and these splashes are much higher. So what I'll do is I can use custom values over here. I can use 10 over here and make exponent like 1. So it's going to be like a really thicker fluid. And if I bake this one now, you will be able to see what this actually means. So really higher value in diffusion The lesser the exponent is, the much stickier it's going to get. And so 10 and 1 is the example, the setting that you would want to use for really thick, like a chocolate like liquid. And over here, let me just zoom in so you can see it better. It's sticking to the surface, it's moving slowly, and there are no splashes going on over here. And if I decrease the speed of the simulation, this is going to look even better. So I'll increase the sampling over here, just bake the simulation. So now that we have more particles, you can see the effect much more clearly, how it's actually stacking and behaving like actual chocolate. Combined with the time scale, you can actually achieve some really good thicker fluid simulations with this one. So Mantaflow still doesn't have a very great viscosity that you might have seen in the flip fluids or other simulators, and I guess it's still work in progress, and there are some work which is already in development for viscosity. I'm not quite sure. You might have to go to the forum and check it out for yourself on the development portal, but I believe there's still much more work is required for the diffusion and viscosity parameters. So yeah, we have some chocolatey simulation going on over here. And if I make mesh for this one, you will be able to see some chocolate-like simulation. Yep, this looks good. Yeah. So play around with different settings of the base and exponent, and just see what the different combinations means. Just study more about it if you need to. You can always press F1 onto any parameter, and this will take you to the official guide. And over here you can see different like chocolate syrup have this much viscosity, honey have this much. You can play around and put these values into simulator and just observe the results. But keep in mind, this is working because we have time steps set to like 16 and 8, and it will behave completely different if we have very less samples. If we have the default samples, then the viscosity is not really going to give you any good results. It's going to just yeah, over here you can see we have like it's not actually sticking to the surface, it's just falling down. So time steps is something you need to always keep higher for quality results. All right, because we have less particles for solver to calculate the motion of the thicker fluid. That's why you can see it's not actually giving you good results. And now I have given it 24 time steps, and now you can see there are much more calculations happening, and it's stacking even more neatly. All right, so that's about it for the diffusion. And the one more thing about diffusion is it's not just about the thickness of the fluid. It also kind of gives it a sticky behavior. And just to clarify that, I'll make a new example. Let me just make a full copy. Over here I have this very basic cube. This cube have normal velocity of 4, and it also have z velocity of 1. So basically the fluid is just going to just splash up. So yeah, that's about it. And the viscosity, the diffusion is enabled. I just want you guys to see something. It's not just the thickness of the fluid that you can simulate with the viscosity. You can also sticky behavior, like the fluid is going to get sticky behavior with these diffusion parameters. So right now you can see the fluid basically bounces up and sticks to the surface that is on the top and falls back down. Now if I just play this one, you can see it's kind of sticky. Now this will be much more obvious if I give this let's say some more velocity, and let's give it some surface tension. It's going to make the overall fluid a little bit shaky. All right. I think I can increase the normal velocity more, maybe to 10. Let's shoot this up. All right, I'm going to bring these samples down just so that we can iterate much faster. 8 and 4. So you can see it's just sticking to the top surface. That's because we have diffusion enabled. Now, if I disable the diffusion, then it's just going to behave like water. It's just going to bounce up and come back down. And let me just make one collision torus over here and make this one effector collision. Let's give it more velocity in the normal direction and more surface tension over here. So now you can see the fluid is sticking to the top wall and this collision object. And this shaky behavior that you see, that is because of the surface tension. Now if I increase the samples to 64 and if I make normal to 25, the normal velocity, so that we have some crazy splatter going on, then we should see something really crazy over here. So it's a really sticky surface, and you can see there are a few samples over here. Yep. So this is a really interesting example. I'm just going to make a full copy of this, and let's make it even more wild, and let's make it let's make the z velocity to 10, and let's see what happens. Yeah. Now we have like a big splatter going on, and I really like this. I think it's a really cool effect, and it's going to stick to the top surface or any collision surface because of the diffusion parameters. So after that we can just mesh it. Yeah, so that's about it for the diffusion, and I'll just make one more really cool example out of this. I kind of like this result, so I just want to play around with this a bit more. All right. Yeah. So what I did was basically I made the z velocity less so that it moves more in the local direction of the normals instead of just going up and just sticking to the upper roof. So now we have a slightly different splatter going on. It kind of looks like a web. Yeah, so this one is going to stick to this surface, and we have really cool looking results. All right. So that's about it for the diffusion part, and I think now we can just talk a bit about the mesh part. We'll talk about the particles in the next chapter. There's nothing much to it, but still it would take a completely different scene and prepare it carefully. So by default, the particle radius is set to 2 and uprest is set to 2. And if you bake the mesh with these, this is what you get. And if you zoom in, you'll notice your particles are much smaller, and the mesh is kind of blobby, and it has a gap in between them, and it's because our particle size is set to 1 in the simulation, but in the particle in the mesh it's set to 2. But if I want to pack it really closely, I'll make it 1 over here as well. Now you'll see a much finer mesh, which is wrapping really close to the to these liquids. All right. So this is not a really great example to discuss the particle meshing. I'll just go back to the collision scene that we made. Now there are two aspects about the meshing part. One is setting up the mesh parameters over here, And the second thing is detailing your simulation in a way that it will help your mesh. So eventually the mesh is only going to wrap around the particles, and if there are no particles, then there's not going to be much, and it's going to be a really dull looking mesh. All right, so if I enable the mesh into this, a pretty decent looking mesh wrapping around it, and that's because over here particle radius is set to 1. Now if we make it to default value, then in that case it's going to look like a really blobby mesh, which is nothing close to the actual simulation. Over here you'll see so much gap. That's because the mesh is calculating each particle's radius to a double of the actual particle radius. And in some cases, if your mesh is ignoring a lot of particles, then you can keep it to 2. But otherwise, I often find it too much. So either at least make it 1.5, and this should be enough. I think I can make it even lesser, 1.2, give you a much tighter mesh around your actual simulation. Over here you can see now there is a very less gap, and it looks there are very fine strands, splashes that looks less blobby and much more refined. You can also make it 1, but in this case it would ignore some particles. So what you can do is you can also increase this resolution. Actually, this is kind of risky for larger sims. It could get really heavy. This will help you pack more geometry around each of the particles. And over here you can see if I make this one 1, then I have like really flat geometry going around these particles. It's not really actually taking a nice shape around it. If I make it 3, then it should make some better. Yeah, it's not quite good, but at least it broke it down into multiple chunks. And these parameters lets you smooth out some of the negative and positive areas, and I think leaving it to default should be fine, but feel free to play around with this one. And these two will help you, like if you have like too much of concave holes going on which you want to fill up, then you can use these parameters over here. So it's self-explanatory, and there's nothing much to discuss about this over here. All right, and once you are done with the simulation, it's not going to render the particles in the render. But in case in the viewport, if you want to find it distracting, you can always disable liquid from here, and this will give you only mesh and not the liquid. And let's say if we make it 4, I hope it doesn't get too much, but this will give you a very nice, tightly packed, dense mesh, good enough to accommodate a lot of particles that were left behind. Yeah, in this case, I think if I can increase the particle radius to 1.1. So that's about it for the meshing part. There is another tutorial that we discussed in the past, which was about CGI for product advertisement, and we remade the Mantaflow section a few months ago. There are a few things we discussed in that particular scenario, so you can go and watch that chapter as well. All right guys, so I think we are done with the meshing part as well. Now let's talk about the guides, and after this we are going to make example that we've seen in the trailer. So I'll just make a new scene, and for the guides I have this very basic scene set up. So the way the guide works, basically any other object in the scene that you want to use the velocities from, you can do that with the guides. Let's say if I have this cube over here, and there's another key. Let's shift this animation slightly ahead so that it happens after the fluid is settled. Now on this one, I'll apply fluid physics properties and choose the effector. So far we've been dealing with collision. Now let's make it guide. And over here you can see velocity factor. Now how much velocity you want to drive from this one. Let's leave it to default. But to use this guide, what you need to do is enable the guides from here in the domain setting as well. And from the drop down velocity source, we are going to choose effector. We are not going to talk about domain at this moment. It's a really complex thing. So let's talk about effector. Now it's going to calculate all these effectors while calculating the sim. So since our playback is the cache type is set to replay, then it's going to calculate everything simultaneously. In case this is set to modular, then in that case, you'll have to bake your guides first. After that, you'll need to bake your simulation. All right, so I'm going to change this to modular and bake the guides. All right, now the guide is baked. Now let's bake the data. All right. So now if I play the animation, you can see first the liquid settles down, and when the moving object passes through it, all that velocity that is being added to this the domain with this effector is actually adding to the motion of the fluid. Now you would think this is possible with the collision as well. The difference is it's not actually colliding with it. It's not really creating a boxy collision shape around it. If this was a box, then my particles would form around the box and then splash. And that is a different thing. And this is not exactly the same. After this, you can also control how much velocity you want to transfer from this one. All right. So that's about it for the guides. And I just want to give you one more example. This was about passing an object through it, but we can also use guides velocity even if it's not passing through a fluid. And for that, I'll give you another example. I have a different scene set up just for this purpose. So in this, if I isolate these two, in this, it's not actually passing through an object. This turbine is kind of rotating, and this is set as effector and guide. All right. And I did the same thing. I baked the guide first and I then baked the simulation. And see, even though it's not touching the liquid, it's just adding velocity within this domain. And because of that, you can see it's generating a wave. So you can use this for let's say if you had some hovercraft or something running on top of the water, and you just want the velocity from that the turbines or the objects to affect the waves of the simulation, that you can do with this. All right, I hope it's clear. And so just play around with all these settings. It's really fun thing. And like I said, the simulator in itself is nothing much. It's just going to give you dead drop water, and you'll have to detail out things to create some exciting effects. Now right now it looks way too splashy. I can decrease the velocity factor, and then after this, keep in mind I'm using modular cache type, and because I don't think in the replay section, replay mode, the guides were working properly. Now you'll see a much lesser velocity being transferred into the domain. So it's not splashing all the way to the top because we reduced the velocity factor from this one. All right, guys, so that's about it. And now the rest of the parameters are only about the caching collection. Like if you want to use multiple flow sources and the effectors, you can always make collections out of it and use it over here. And in the cache type, you can just choose a folder where you want to save your sim. And there are different kind of cache modes, and OpenVDB is a good one. Use that. And over here in the field weights, you can, if you have force fields going on in your scene, you can adjust the influence of those force fields over here. Yeah, so we haven't really talked about the force fields, and I'll do that right away. Full copy, turbulence, force field. Now, unlike the previous simulator, force fields work with the liquid simulation now. And if you bring one turbulent force field over here, let's assign some limits to it, and let's make it 5. All right, and place it over here. I'm going to just animate this one. Let's assign location over here, location, and pass it through the fluid and bring it over here, location. If I bake the data, then you should be able to see the effect of the force field. Like over here, there is no influence of any field, and as soon as this moves inside the domain and interacts with the fluid, you'll see some nice curls going on and affecting our fluid. So you can create some really exciting effects with this, combining force fields. So that's one more thing. And also keep in mind, you can always animate any of these properties. Like most of these properties are animatable. Let's say if you want to animate at which point the emitter should throw in the liquid, then you can key, like over here you can see I have these at the frame number 4, I pressed I over here, and this enables the key, animation key, and over here I turned it off and pressed I. So you can see the key over here. And you can also, like the velocities, you can animate. You can also enable, in fact, I think you can enable animate the diffusion parameter as well. Like let's say if you had something sticky at first, and after that you want it to drop down, then you can just animate the diffusion parameters. So all that is like really fun stuff. I'm going to make a full copy of this again, and now if I change this to, let's say, vortex, I'll rotate this one over here in this direction. Now if I free the sim and bake it again, all right, so now we should have a vortex motion in the fluid. I'll just bake few more frames. So you can create some nice waves with this, and combine multiple force fields and create something really exciting. So that's about it for the basics of liquid simulation. And now what we're going to do is we are going to create a very basic scene which you've seen in the trailer. Make one scene around the Suzanne model and pour some gold on top of it. So it's going to be really basic sim. I don't think we are going to discuss anything out of other than what we have already discussed. So just for fun, just so that you have something to look forward to and make some nice render out of it. Feel free to explore some other example, but I'll just conclude this chapter with Suzanne scene. All right. Now let's bring one Suzanne over here, rotate this around like this and rest it on the floor. So let's go to the front view. Yeah, this looks good. I'll apply a subdivision surface, and I'll also make a copy of this and place it over here. Let's make one camera, Ctrl-Alt-0, and now let's frame our scene around it. Something like this. I want to compose my scene around it, and for that what I'll do is maybe if we can bring this one closer to the camera and face it over here, something like this. Let's move it down, move the camera down a bit. So we have something in the foreground and in the background just to add some depth to the scene. That's about it. So on this one, I'm going to add fluid physics properties and make it into effector, collision, and give it some thickness. And I'll ignore, hide this one for now. And on top of this, I'll add one cube. Instead of one flat cube throwing in the liquid, I'm going to make it a slightly more detailed. I'll make multiple small chunks like this, and I mean the emitters of different scale, so that we have some variation instead of just a flat cubical particles falling on top of it. And now what we can do is bring one empty. Let's make it circle. R90X, move it up over here, and let's parent these emitters to this empty over here. What we'll do is, let's change this to animation. We are going to animate this empty. Let's move it over here, go to the frame 35 or some other frame, move it over here, so that we have a motion in the liquid and it looks like it's moving, and something like pouring, and instead of just a flat lines, it will add to the motion of the fluid. To this I'll add a flow, and make this one into liquid and make it inflow. What I'll do is I'll add a key to the surface emission. Now what this will do is, if I go to the graph editor and add one modifier which is noise, now this surface emission value is going to animate. Now the reason behind this is, instead of always liquid always falling down in the constant thickness, like whenever the surface emission increases, it's going to give us more fluid, and whenever it decreases, it's going to give us thin lines. So it's, instead of flat lines, our fluid will be something like this. So that's the reason for doing this. I just want to add some variation to it. Sorry, strength. Yeah. All right. And maybe few more smaller pieces over here. Now let's add one cube around it and make it just big enough so that it doesn't really add too much into the scene. I'll move my emitter upwards just so that it doesn't shows up in the camera. Yeah, that's about it. Now let's give this one domain and leave it to 32 for now. Let's increase the substeps and give it diffusion. Sorry, this should be liquid. Enable the diffusion, make it around 10 to, let's animate this and see what's going on. I'll make it modular and bake the data. So we have some simulation going on, and as you can see, it kind of looks like it starts and it stops. And the reason behind that is because we have animated the surface emission over here, and right now it looks too much. I mean, it looks too thick, and I'm going to decrease the strength. So over here it looks really thick. I mean, it's 1.3. So let's make it 0.5 or something. And also it seems like there is not much liquid being emitted from inside of these cubes. Now to solve that, you can just give it a very minor z velocity, 0.01. I think it should solve our problem. When emitters are very small, the liquid kind of gets stuck to it. So you would have to give it some z velocity. Okay, I'll just disable this noise for this moment so that I can see how much liquid is being emitted from the volume, because it seems like there is no fluid emitted from the volume at this moment. Yeah, you can see it's a very few particles. So to solve that, we can increase the resolution because it's a very small, tiny liquid source. Now this should give you liquid from the volume, and now we can enable the noise in the graph editor, and let's bake it and see what's going on. Now before that, I'll also slow it down to 0.5. all right, and increase the substep to 16:8 and bake the data. All right, I have very few frames baked at this moment, but what I've noticed is the noise value that we are given into the surface emission is not quite subtle. It's too much, and it's happening too frequently. So because of that, there's too much of wave going on, and I want to stretch this noise something like this so that it's not too noticeable but very subtle, and decrease the strength to 1. Now let's bake it again. All right, so we have some simulation and it looks something like this. Honestly, it's better than what I had created for the trailer, because after the trailer, when I started studying the time steps value and all that, I found it very useful. I wasn't quite aware of the effect of the time steps in the liquid simulation. This looks nice, but what I'll do is I'll provide this file, whatever examples we have discussed so far. If you want to revisit these examples, leave the file on the gumroad. All right. There are a few things I would have to tweak. One is the speed, and for that we can decrease this number time scale. And second thing is these bands look too thick. I think I can tweak this emitter down a bit. Let me just make this one smaller And this variation in the thickness you see, that is because of the noise that we have given in the surface emission. I'll just decrease the time scale to 0.3, and I also want to make sure like the fluid first appears on top of this, and after that it goes on the right instead of in the back, because that wouldn't really be visible in the camera. So I'll just scale it down overall in the emitter. Yeah, this looks good. And Z location, I think I can bring it down a bit because it's not visible in the camera anyways. I'm working with a graph editor because it's an animated object. So I hope you guys know how to do that. In case you don't know it, please watch the introduction series. All right, I'm going to bake this one and come back in a moment. All right, guys, so the simulation is done and this is what it looks like. I think this works quite well, and in the camera I can see it's falling in the foreground which is visible in the viewport, and there are still few things which I would want to tweak a bit, but more or less I think it's working fine. So what I'll do is I'll just make few more tweaks and I'll rebake this entire simulation on 128 resolution. Now just so that you can see the preview, this is what this one looks like with the mesh. So once I bake this entire simulation on 128, I think it will have much more detail in it, and I can also increase the resolution of the mesh by one I guess. So more or less we are done. I just want to make a few more tweaks and I don't really want to drag this chapter much further. I hope you get the idea, so I'll just get back with the final results. So see you in a moment. Alright guys, so here's the final file, and this is what the final simulation looks like. As you can notice, it looks much more tighter. The mesh is wrapping around pretty tightly, and after doing few tests, initially I baked it on 128, then I realized the mesh was still looking a little thicker and there were very few particles. So I pushed the resolution even further. I made it 256 resolution, and this took me around 4 to 5 hours, around something around that time, to bake the entire simulation. Now one thing you may have noticed over here is I reduced the time steps. Now the only reason behind this was to speed up my simulation, but if you notice, this have slightly less interesting motion to it. I think this motion can be improved if we utilize the time steps. So somewhere between 128 to 180 resolution also works fine, and I just don't want to bake more and drag this tutorial for further. I think a right balance would have been around 180 resolution and 8x4 time steps, something like that. You guys can try it out and let me know what is the right balance you find. And I think this looks pretty good. It's wrapping around pretty well. It's taking the shape of the head of the Suzanne. I can see the silhouette from here. If I isolate the fluid, I can see the nose and eyebrows and everything. So it looks good. So this concludes our tutorial. Introduction to the liquid simulation is complete over here. And if you are here only for the simulation part, that's all we have for today. But for those of you who want to render it further and make something, some good output out of it, then we are going to talk about a bit of a render setup that we have done for the trailer purpose. So the first thing I'm going to do is we already have a camera, and one more thing, if you notice over here, is there are two fluid sources now. I added a few more boxes in the front which are pouring fluid on this Suzanne. This is just so that we have some more interesting elements going on in the foreground, and it's not just one Suzanne head which is the center of the attention. For this, what I did was within the same domain, I extended the domain and I added a few more emitters over here, and on these emitters, if you see, we have animation keys, and this emitter activates around frame 50 if you notice over here. That's the only thing. I hope you already have the idea of what all is going on. We discussed so many examples, so this shouldn't be a big deal for you. Alright, so let's set it up for render. the first thing we are going to do is make sure we are using the cycles render. So I'll enable the cycles render over here. And since we might be using displacement for this, so you would want to use experimental feature for this. And CPU, GPU, that is totally your preference. So I'll add a background plane to this first. I'll add a plane over here and go to the edit mode. Let me just enable the screencast if you guys need it. Let's extrude this one in Z direction and make it something like this. Control B, and this will give it a bevel. And maybe you would want to rotate this and make sure everything is filled up in the background. So for the visual, I want this to look like some sort of ancient temple, like some old ruins where all these Suzanne models are just lying around and weathered, and everything have some sort of a very ancient look, like very dull materials. After that, we pour gold on it, and that element also merges in the background on a black shader, and everything kind of starts morphing into gold. So the setup is quite simple. There are only two materials. One is the gold and one is the black material. And we are going to kind of mix it up with one texture that I'll provide the link for, which is actually from textureheaven.com. All right. So let's make the main two shaders first. I'll select the Suzanne head and just enable the render preview over here. Let's bring some test HDR so that we can see some stuff in the light. So over here I have a very basic principled BSDF. I want to make this one into a black material. Let's just make this color black. Maybe we can give it some sheen and some anisotropic and reduce the roughness a bit. Something like this. That's about it. And this is the black material we need for our purpose. And let's make one more material, which is going to be the gold material. And for this, I'll just bring some golden color over here, and let's increase the metallic all the way. And that's about it. We'll improve these materials with some sort of textures later, so don't worry about it too much. So these are the basic two materials. Now what we need to do is make it look not so basic. We are going to bring some texture in this one. I'm going to use displacement for that. And the reason behind that is, if you have seen the opening shot, there is a lot of displacement going on, and there are kind of creaks which are like golden and black materials mixing up. We can basically use displacement to bring some roughness in the ground, make some rocky looking shapes. All right. So I'll just add a displacement over here and plug this into displacement, and make sure in the materials displacement is enabled. Over here, by default, this is set to bump only, so you can change this to displacement and bump. I'll isolate this model so that we can see the previews faster. So right now it looks messed up. So I'll just cancel it and bring a image texture over here. Let's bring one texture, image texture, and let's open a texture that I brought from HDR Heaven. And from this pack, I'm going to use this displacement material over here. I'll plug this one into the height, make mid-level 0 and the scale 2.4. All right, now plug this one into displacement, and this will make the entire model look like a bit rocky and rough. Now, if you want to actually use this displacement to deform the geometry, then you would need to use the subdivision surface modifier on this one. After that, you would need to enable the adaptive, and this will actually deform your geometry and give you rough edges like over here. All right. So, but I honestly didn't use the true displacement for the Suzanne head, but I only used this for the ground and the top part. So I'll disable this. I don't really need this one. I think without the displacement, this looks just fine. So this is the main ground and the Suzanne material. After this, we need some sort of roughness in the material of the gold. For the golden material over here, we are going to break it down with some roughness. We are going to use procedural material for that so that we can animate and simulate like the texture is actually moving with the gold. So let's bring one Musgrave texture and plug this one into roughness. I'm going to bring one, let's bring another texture which is going to be noise texture and plug this one into the vector of the Musgrave, and let's bring up one more noise texture and let's plug this one into the vector of the Musgrave into the noise texture. All right, we can make this one into 4D and 4D, and that way we can animate these values. And now if you press Ctrl T, this will give you texture coordinates, and if you move the Z value, then this will look like as if the texture is moving along with the gold. So we are going to animate this value later. Now if we preview the entire material, this is going to look like something like this. Now if you feel like just changing the contrast a bit, you can always use brightness contrast a bit. So I think this looks fine, and there is nothing much though, but it's better than the basic material that we had. Something like this. Alright, so just play around with the texture size and the different values and find the right balance for you. This one is our gold material. I'll rename this one to gold and rename the Suzanne head material to black material. Okay, so I think pretty much we are done. We just need to add some lights. So I'll give you a breakdown of what is going on with the lights. So for the lights, I added one backlight, which is actually throwing light from the back over here. And this is a very simple point light with a very high intensity. You can see over here, I have this light, which is shooting from the back. Let me bring one top view over here so you guys can see the placement of the light. So this is the main backlight, which is creating some sort of rim around our Suzanne head. And there is one more backlight, which is kind of filling in the empty areas on the right and adding some more rim over here, and into the gold we can see some more brighter areas. For the front, I used two lights. One is a still light and one is an animated light. The animated light has some sort of a very basic motion, and because of that the shadows kind of move, and this was kind of adding into the scene, so I kept it that way. So I'll just show you the fill light first. This is the fill light. Let me just show you the effect of this. So this is the fill light, all right, filling in all these right darker areas. So the intensity is like mid-range over here, like 500 over here, and this is lesser than the main light, which is shooting from the back. And then there is an animated light, and this light is placed quite closer to the ground, and the intensity is very low for this one. So you can see where all this is affecting. And if I bring the animation timeline over here, you can see this have animation, and the light is actually moving. Just to show you the effect, you can see the shadows traveling over here. These shadows change the direction when the light moves. So that's just a secondary animation for a bit of a detail. So that's about it. This is the full setup of the scene. Now the only thing we need to do is we need to add some sort of gold into the black material as well. So right now we have black material and gold materials. What I wanted was as the liquid is pouring down, some of that gold is actually emerging over here and blending into this material. And as you've seen in the trailer, the shaders kind of look animated. The mix value of these two shaders will change and animate. So I'll just show you what I mean by that. So let's just grab this gold material, copy this shader, just these two nodes, and grab the Suzanne head and paste it over here. So we have one black material and one gold material. All right. Now we are going to mix this one with the mix shader. And whatever values we are using in the displacement, these values, we can use these as factor to merge these two materials. So let's take the very same texture and plug this one into the factor of the mix shader. I'll isolate this model so that we can see effect better. So right now this texture is kind of gray, and to actually make use of this, we need some more contrast so that these materials are not really just going 50-50 and there is good contrast in it. So for that, I'll bring one brightness contrast and plug this one into this over here. So let's make this one 0.5 and let's increase the contrast. Yeah, now we have some stark black and white values. And now let's just multiply these values a bit. And now we should see a stark combination of black and gold. Let's swap these two materials. Yeah, so as you can see, when I increase the multiply, this adds into the gold over here. All right, and you can also decrease the contrast if you want to spread the material more on the surface of the Suzanne head. And if I bring everything back, you'll see how the same material is also affecting the background. So that's about it. This is the whole setup. Now the only thing we need is we need to render out from multiple camera angles. The sequence that you're seeing, first I wanted to basically introduce the two materials, black and gold. So it's sort of like a fountain. The opening scene you've seen, it's like the gold is dripping from some sort of creeks. So basically I used the same plane that you see on the ground over here, and I increased the displacement value and applied subsurface division on this one. So that we get those tall displacements. I'll just show you the file in a moment. But first I wanted to discuss the few shots. So this is the main establishing shot that we get after the opening shot. All right. Once you have this one, what you can do is you can just make multiple copies of the camera. So let's make another camera copy. And this one we can choose as the gold pours down. We can also get into some sort of different close-ups. So I like this camera angle over here, and I'm going to decrease the length of the depth of field. And for this, I'll bring one empty over here and assign this one into camera. All right. So this was for the close-up shot, and there was another shot which was somewhere over here. So I brought another empty object over here. Let's bring one empty object over here, and let's choose this one for the focus. And in this case, rotate the background other way around. So once you have the main shot, the rest everything else should be quite easy. We are just rendering the same sequence at a different moment from different camera angles. And one of these shots were in the extreme close-up of this portion over here. Yeah, something like this. So this was one of the other shot, and then there was one shot about just these golden lines pouring down. And one of the other main shot when which actually covers this from the top. Over here, basically what I did was as the camera animates, I animated the value of this material. I made a duplicate of this black material. As we move forward in the animation, the gold kind of takes over. Yeah, here. So the gold kind of takes over. So this is the default material, and when the camera moves more towards the right, I animated these values so we see more gold in the background. All right. So that's about it, guys. This is the whole setup. I have multiple cameras, and after that, the only thing you need to spend some time is think about the music and think about the edit. So think about how you want to lead your entire sequence. Like the main idea over here was this was some sort of ritual. Okay, it's like these ancient Suzanne models are just lying into ancient ruins, and as we hear the music goes on. It's like some sort of holy ritual going on. The music kind of gave me vibes of it's like healing something. So I know it's kind of over dramatic for a simple Suzanne tutorial. I just kind of got this good vibe, so I just went along with it. So you feel free to explore more ideas you guys have. This is just a fluid simulation tutorial. I didn't really want you to narrow this down to just one idea. So this is just to give you a hint and make this tutorial a little more fun than just a splash tutorial. All right. Yeah. So the opening sequence, I'll just open the other file which I have. So for the opening sequence, I kind of did the same thing. It's these rocks have quite a basic black material with a bit of golden hint. What I did was I made these boxes into collision. Just to give you a hint, I basically made one cube over here and just extend it. This is just for beginners. I don't think there's anything much going on over here. Subdivisions. And after that, you can just smooth this out with proportionate editing. Move these edges downwards and just give it some bevel so that we have some sort of a path for the fluid to follow. So over here I have two emitters. This cube activates around frame 120 and this cube activates around the same time, and both of these are throwing fluid, and which is actually the gold material, and these will follow the path of the mesh. So if your mesh doesn't have any concave material, then fluid is just going to drop it from the sides. If I go to the frame number, the 110 or something, like early frames, you see these kind of like icicles, how the icicles freeze in the mountains. So we have golden and black material over here, which is kind of forming these vertical rocky looking shapes. All right, and from here it leads to the golden, this fluid pouring down, and after that we can cut to the other file. So that's about it. And for this one to work, just make sure you using the subdivision surface. Let me just bring some other HDR. Yeah, so I have subdivision surface applied over here with adaptive enabled. It's the same material, and it's just that the displacement is kind of I increased the level of the displacement. So over here you can see we were using 0.4 before, so this was the ground material, and now we using 3.6. So this is just a very quick job. I mean it's just for this tutorial, guys, so nothing too fancy over here, just that you need to put some thoughts into it. So that's about it, guys. This concludes our tutorial, and I hope you guys enjoyed it. And do let me know what you guys are working on, what kind of scene you are making around the liquid simulation. And it's not always necessary, but I find this practice very good, and this is especially for beginners. Whatever practice you're doing, even if it's just a small model or small simulation, just don't make any rough experiments. I mean, you can do early rough experiments, but eventually try to build a small scene around it and render it out. Because whatever we are learning, all of that is for animation purpose, and it's for telling stories. So whatever you're making, if you put some little more thoughts into it, however basic it is, give it some meaning, and you will feel good about it, and it will look good. And when you're thinking into a context, your thought process will be slightly different. You will have an objective and aim to meet. All right, so keep that in mind and have fun with it. I look forward to seeing your results. Tag me on Instagram with Crossmind and share your simulations and your post with me. And for those of you who are new to this channel, please subscribe and let me know in the comments what you find useful, what doubts you have, and in case you get stuck at any moment, please detail out your comment and don't just post "I'm stuck at this moment and I don't know how this works." I won't be able to help you in that situation. Just post a video or detail out your comment like, I was following these steps, and after that I see these results. I don't know what is going on, and these are the details of the scene. Okay, in that case I will be in the better situation to help you out, and I'll try to be responsive as possible. Also, the next chapter is going to be about the fluid particles, where we make a wine glass and like wine or beer or something like that, and make foam on top of it with the particles. And this is what it's going to look like. And the later chapter, it's going to be about using particles with the liquid simulation. So using those to make rain with the liquid simulation. All right. So there might be a few more. I'm not sure. I'll see if I come up with some more ideas. I'll share it with you guys. And this file, what you see over here, this one and this file, and all the other examples that we discussed earlier, however small those examples are. I'll keep those files in my Gumroad account, and because some of you have requested that I should post my project files sometimes, and this I guess I can share. So you guys, if you want to revisit it, or if you want to just play around within the same file, you can download it from my Gumroad account. It's not for free, but it's very cheap, just in case. All right. And also I'll try to post the chapter number 6 for the animated content creation series by coming week. And that's about it, guys. And I know a lot of you have been waiting for the explosion tutorial. I just want you guys to know, I think it's just around the corner. I just want you to be sure about a good method of creating explosion, and not do like a guesswork or like a give you something which you wouldn't be able to apply on every scene. So I'm just trying to build a strong foundation for the explosions, like what are the concrete steps you need to take. And so I'll post it as soon as possible. I look forward to see you guys around in the further chapters as well. Do enjoy your day, do practice hard, and share your results. Share this channel with your friends, your colleagues. Give it a thumbs up if you like the video. I'll see you guys in the next chapter. Thank you. Goodbye. Have a good day. Bye.